All right, let's look at an example of 0 to the 0 indeterminate form for L'Hopital's rule. All right, let's evaluate this limit. All right, so as you can see, as x approaches infinity, the 1 over x approaches 0. And if the power is the same, approaches 0. So you have a 0 to the 0 situation. So we can apply L'Hopital's rule. All right, so before we do the L'Hopital's rule, what we're going to do is we're going to make this manipulation here. X approaches infinity. We're going to apply e to the natural log. It looks kind of strange. E to the natural log literally does not do anything because log functions and exponential functions are inverses of each other. So basically they cancel each other out. But if you apply that to 1 over x, raise it to the 1 over x. All right. So what we can do is, actually 1 over x. This is what I meant. All right. Then what you can do is using a log property to bring this guy right in front. And also, exponential function is, a continuous function. We can actually squeeze the limit inside the exponential function. So we can rewrite it this way. So it's going to be e to the, so we can kind of forget about it for now. Then we just have to focus on taking a limit as x approaches infinity. All right, so you have a natural log of 1 over x. So natural 1 over x is x to the negative 1, so I'm going to write it this way. All right, and the 1 over x here is brought outside, so it's going to be over x. All right, so we have that. All right, if you want, you can actually place this guy right in front. All right, why don't we do that? So I'm going to scratch that and put a negative sign here. All right, then now we can apply the L'Hopital's rule because we have infinity here, and here numerator is actually going to negative infinity, right? Negative natural log of infinity, right? So by applying L'Hopital's rule, we have, so you have e to the, so limit as x approaches infinity, and derivative of negative natural log of x is negative 1 over x, and derivative of x is 1, right? So you can see that 1 over infinity is 0, so this guy approaches 0. So you end up getting e to the 0, which is 1. Right? So the limit of this original 1 over x over to the 1 over x is equal to 1. All right, so the trick is using e to the natural log so that we can use the log property to turn it into 0 over 0 or infinity over infinity situation. All right, that's it. I hope that this was clear.